Alright guys, it is Tuesday. I'm just going to give you like, I don't know, 5-6 minute video here. We're doing a Google Meet at 1 o'clock today. So I don't even know if you'll see this before then, but I'll go over worksheet number 1, the math worksheet 1 due today. I will go over that in the Google Meet. And I'm going to post worksheet 2, which will be due tomorrow. You also have your free response due tomorrow. And we'll talk more later. But I wanted to just go over, I got 3 percentage problems here that I just kind of made up this morning that'll help you do worksheet number 2. So you can watch this if you want. So basically, on this cheat sheet here, your percents would be rate of change, which is typically a percent. See, it's the same formula, you just multiply by 100. And then, let's see, what was the other one here? Actually, that's it. I mean, the other worksheet covered these, but percentage is part over whole times 100. That's easy stuff. I mean, you learned this a long time ago. But I'm going to show you different ways to do percent problems. Here we go. Or different types of percent problems. So here we go. I'll give you 3. 200 acres of trees. Over 10 years, people plant trees and the area increases to 1,000 acres of trees. Calculate the percent increase of acreage covered with trees. So, you know, it's kind of a very simple way I worded that. And the point is, you have a question on the exam where they give you a certain amount of, I don't care what it is. It could be pollution levels, it could be trees, it could be acres, it could be cars, it could be people, I don't know. If that number increases or decreases, you should be able to calculate the percent increase or percent decrease over, and it could be per year or over a certain amount of time. So we went from 200 to 1,000. So the percent increase is over 100%, right? Because 200 acres, if it doubles to 400 acres, that would be a 100% increase because 100% of 200 is 200. So this equation here, and if you guys can think of these numbers and do things kind of your own way, you don't need to use these equations, but you are, right? There's kind of only one mathematical way to get the right answer. You can just do that different ways. So maybe the mathematical process or concept is the same, but the way to do it is a little different. But anyways, we'll do old minus new over old times 100. What does that mean? Well, if I take 1,000 minus 200, that's going to give me 800. Well, if I divide that by 200 and then multiply it by 100, that's going to give me the percent above 200. Meaning, like I said when I was explaining, if you double the acreage, 200 to 400, that would be a 100% increase because 100% of 200 is 200. So if you add 200 acres to already 200 acres, you're doubling it, which is a 100% increase. Oops. But if we're going to increase it by 800, what you end up getting here is 800 divided by 200, right? And 800 divided by 200, you can cross off the zeros. 8 divided by 2 is 4. So 4 times 100, you're getting 400% increase. The reason I picked this one is sometimes kids get confused when it's above 100, right? So if I said, all right, you have to start with 200 and you end up with 300, then everybody, I think most students understand, you know, it's going to be somewhere between 0 and 100. That's what people always think, right? But not if you're going above that, right? If you're adding more than 100%, then it's going to be above 100%. That didn't make sense, but it did in my head. It didn't make sense out loud. But anyways, that's why I picked that one. All right. So hopefully that makes sense, despite some of my mumbling and confusing words there. All right. Next one. You're going on a trip. You have driven. Oops. So you're going on a trip, and let's say you're with a couple people, and you take turns driving. So you drove 150 miles of the trip. And that is 15% of the total trip mileage. How many miles is the trip in total? So I'm using the same words again there. So let me rephrase that here. So you drove 150 miles, which is 15% of the total trip mileage. So I want to know how many miles in the entire trip. All right, that's the gist of it. So if we know 150 miles is 15% of the entire trip, right? So here's the road. Let's say this road is the entire trip. So here's start, here's the finish, right? Start, finish. And you drove, I don't know, let's say that's 15%. So you did this, 15%. And you know that's 150. Well, then how much is from here to here, right? What's the total trip? So you could take that and say, oh, 150, 150, 150, 150. And then you could kind of do it that way. But that's kind of crazy. But that's the concept, right? You did 15%. What's 100% of this trip, right? What's the rest of this? And then you can add it to that. Or, there's two ways to do this here. Hopefully the drawing made some kind of sense. If you take that and divide by 1.15, you get your answer, right? Because here's the math behind that. If you take 150 times 0.15, you're taking 15% of that number. We don't want 15% of that number. We want the opposite. We want to know what's the other 85%, and then you have to add them together, right? So 150 divided by 0.15 is 1,000 miles. So that's your entire trip, right? So basically, if 150 is 15% of 1,000, then you know the total trip is 1,000 because it told me 15% of the way is 150. Here's another way to do that. 15 out of 100, 15% out of 100 is, how did I write that down? Yeah, 150 over x, right? So we want to know if 15% of 100, well, 150 is 15% of what? Cross, multiply, divide, you get 1,000. That's another way to do that. Hopefully that makes sense. And the last one, so this video isn't too long here. What am I up to? So, yeah, all right. Third one, you got a sapling in the year 2000. So 20 years ago, the sapling is 100 centimeters tall. Well, now 2020, you measure that same tree and it is 400 centimeters tall. Question is, calculate the percent change in height per year. What is the percent change in height per year? All right, so 400 minus 100 over 100. This is just like that first problem we did. So it's increased well over 100%, right? Because it started at 100 centimeters. Now 20 years later, it's 300 centimeters taller. So 300 divided by 100 times 100. I know there's a lot of 100s because I used the 100 there. So you have 400 centimeters. I'm not, you know what? I'm being a bad teacher right now. You should always label units. On this test, they need you to label units throughout the whole thing, in the steps and final answer. So 400 centimeters by minus 100 over 100. 300 divided by 100 is 3. So that's 300% increase. That's over 10, that's 10 years, right? So over 10 years, it increased 300%. Well, it's been growing for 20 years. So 300 divided by 20 equals 15% per year. That would be the answer to the question. It's grown 15% per year if it's going from 100 centimeters to 400 in 20 years. All right, hopefully that helps, and I'll talk to you guys at 1 o'clock.